Hey, stat students, we are looking at inference around the design of our studies. What is inference? Well, it basically means a conclusion. So if you see the word inference, think conclusion. So what conclusions can we make depend on how the study was designed. So we're going to look at the components that we're really looking for that are going to tell us how those what conclusions we can make. So we're going to take a look at these excerpts from our textbook. This is chapter 4.3, and this kind of intro to this here gives us a couple examples. The first example happens when we talk about the Census Bureau taking a sample survey and looking at people's sleep right here. Okay. What's important about this is that they took a random sample. So they selected their people in the survey were selected at random. All right. And that's important because a random sample helps us to avoid bias. We talked about bias before. So randomly sampling helps us to eliminate bias from our sample group. And in turn, lets us create some inference about the population. So we can extend our results beyond just the people that were in the sample. We can extend those results to the population themselves. Okay. This right here is an example of an observational study. That's an R. Of course, this is working out great, right? Okay, that's an observational study. And it's an observational study because we didn't manipulate any of the treatments. Like we didn't assign sleeping or not sleeping to anybody. They just took a sample and noticed what was happening with what was already going on with the subjects. Okay. Observational studies, as long as they're random, you can talk about a correlation between the two things. And if they're random, you can then extend those results to the population. But if you want to go to a cause and effect, then you need to get into something that's called an experiment. And that's what they give you an example of down here. Okay. And in this case, with the sleep deprivation experiment, right, subjects were randomly assigned to sleep deprivation in one group and then unrestricted sleep treatments in the other group. So one group was randomly assigned to not sleep. Okay, so they were in the study or in the experiment, like they did a random selector, and half the group had to not sleep, and then the other half had unrestricted sleep treatments, right? But who was in each group was done randomly, which is important, right? That randomness helps us to eliminate uh, bias in sampling, but in treatments, when we assign, that helps us to eliminate confounding variables, right? Something else that's involved, right? Because that helps us to put us into kind of even groups. That random, we take away our own bias by having the random selector put people in there. So that's important because if we randomly assign the treatments, right, that random assignment happens, then we can actually make a statement about cause and effect, right? As long as the results were significant enough, right? Like the differences between the groups were significant enough, like big enough, then those results could then be talked about as a cause and effect. Like in this case, they could say that they could conclude that sleep deprivation caused the decrease in performance. That's our conclusion because the treatments were randomly assigned. This class is an experiment, a well-designed experiment. And that's the difference between an observational study and an experiment. You have treatments that are assigned, that are, that somebody has manipulated in some way. Okay, so well-designed experiment, random treatments, cause and effect. It's just an observational study, but it's random sampling, conclusions to the population, and that's it.